So when you look at an IP address, you're not going to notice it, but for those of us that work in the IT world, we understand that an IP address is broken up into two parts, and that's something that you need to know if you want to get into networking. So when you look at an IP address, there's other components associated with it, which is outside the scope of this course, but if we look at these other components, if we look at the IP address, its subnet mask, and its default gateway, we can determine what network it is on and what portion of that IP address is associated with the actual computer itself. So when we look at an IP address, it's broken into two parts. There is a network portion of it, and there is a host portion of it. So if you look at the bottom of the screen, we have our network address plus our host address. We take both of those, we combine them together, and we have our IP address. Now, I'm going to show you how it works in detail in the future lectures, in the future slides, but before we get into that, I just want to do a quick analogy. So the easiest analogy would be your street address. So whatever your street address, let's just assume that mine is 7682 Wilshire Drive. Now, if we look at that, you're just going to say this is my home address. But if you think about it more in detail, there's two parts to that. There is one that identifies the street that you're on, the Wilshire Drive, but it doesn't identify your actual house number. And then your number, the 7682, that identifies your house. So if we look at our street address, it's actually broken up into two parts. One is for the street, and one is for your house. And so if we take that 192.168.1.25, part of it's going to tell us what network we're on, and part of it's going to tell us what actual host we are on that network. And so that's my quick analogy. Now let's take a deeper dive look into it. So here's our familiar looking binary numbers breakout in our 4 octets for our IP version 4 addressing. And what you'll notice here is that I have class A, class B, and class C, and you'll see that I have network and host assigned here. So what does that mean? Well, what it means is that there's different classes of IP addresses in the IP version 4 schema, and different ones assign a certain amount of bits to a network portion of the IP address, and other ones set aside a certain amount of bits to the host portion. And so what you'll notice here is that I have up the top IP version 4 classful addressing system. Well, what does that mean? Well, what it means is that back in the 1980s and 1990s, whenever they developed IP version 4, the people that developed it, they came up with this system, this classful addressing system, where they determined how they should break out the addresses to assign a certain portion amount to a number of networks that you can create in that class, and also the number of hosts that you connect to each network in that class. And so they came up with a class A, a class B, and a class C type of a system here. And that's what we're going to talk about right now. So what you'll notice is that for our octets, our first octet for class A, only the first octet is assigned to giving out different IP addresses for different networks. And the remaining 3 octets are assigned to hosts. For class B, the first 2 are reserved for dishing out and assigning networks, and the last 2 are designed for assigning to hosts. And then for class C, the first 3 are designed to assign to networks, and the last one is designed for hosts. So what does all that mean? So here's our notation down here to make it look a little bit easier. So for example, 192.168.1.25, if it's class C, and in fact it is a class C, the first 3 octets are assigned to the network portion, and the last one is assigned to give out to hosts. So what's that mean? Well, with this setup here, if you do 2 to the 8th power, that equates into 128. So for class A networks, when they designed it this way, they designed it so they could create a total of 128 class A networks to assign and register and give out to people. And for each one of those class A networks, you could have a total of roughly 16.7 million hosts on each network. And so what they would do is they would give out class A, class B, and class C networks to different organizations that needed them. So you'd have to register and request one. So for example, Google could go to the people that are assigning these out, and they could say, I need a network. And they could say, okay, well, in regards to your size, we will give you class A because we can see that you may need this amount of IP addresses because you're going to have a really large network. So that's Class A. Now Class B, they assigned 2 different octets, which would be 8 plus 8 bits, so 16 bits. So if you do 2 to the 16th power, that gives you a total of, they could create a total of roughly 16,000 different networks for Class B networks. And for each one, you could have roughly 65,000 computers on each network. So for each one of these, you can have 165,000 computers on a network. And then lastly, Class C. So they assigned the first 3 octets, which would be 24 bits. And if we do 2 to the 24, that will allow them to create roughly 2 million different Class C addresses. And for each Class C network, you can have a total of up to 254 hosts on that network. And so if you look at the way that they assigned this, they created it and they developed it so you could have millions of different small networks. You could have thousands of fairly large networks, and you could only have a handful of just insanely large networks. And so the way that it worked is that they would give these out to different people. And what happened is that this was really inefficient. I mean, if you look at this, if you look at the difference, we go from, you could have a Class A network where they're going to give you over 16 million, almost 17 million addresses. And the next step down was a Class B where you can only have up to 65,000. So there's a huge discrepancy here. And then the difference from between here and here, 65,000 down to 254. And so you see why this is inefficient, because when they designed it, they didn't design it thinking that we would probably have, in 10 to 15 years, we would have millions of people connected to the internet across the globe, and there would be hundreds of thousands of small, medium, and large networks where there's needs for network spaces and network designs of anywhere in between all of these where there's a huge gap. So, in hindsight, you see that this is a bad design, but when they designed it back in the 80s or the 90s, they didn't know that, and they never could have imagined that, and they probably assumed that this would have been just fine. So this is inefficient, and that's why we've gotten to IPv6, and that's also why we do something called subnetting, where we can actually take these classes, if somebody assigns us a class, and break them up. And so we're going to talk about subnetting in this course, but we're not going to talk much more about IPv6. But that's what the IPv4 classful addressing system is. And just remember in here that you can either have a Class A, a Class B, or Class C addressing system. And these are the amount of hosts that you can have on each one if you're assigned one of these. But it's inefficient, and we use subnetting to help us break it into smaller pieces. So let's go ahead and let's continue taking a deeper dive looking at IP addressing on our next lecture.